Okay, this is the second lecture related to Chapter 2 of your textbook. In the first part, I covered everything up to the point that we got to turtle graphics, and this video is going to finish out Chapter 2. So, we have something called turtle graphics that comes built in with Python, which means if you install Python, you have the capability to use this module. Turtle Graphics has been around for decades. I remember hearing about it in the 80s, but it is a way, in my opinion, to get you to think about all the appropriate steps that you need in an algorithm to complete some task. So basically what we're showing here on this slide is we have a window that will appear, and in the middle you have this little pointer to the right, and that is, quote, the turtle, and the direction of the arrow in this case to the right is the direction the turtle is currently oriented, and as we'll see, this is currently 0 degrees, which is where it starts out. So it starts out in the middle of the window, coordinates 0, 0, with the orientation being 0 degrees, which again is to the right. Now there are a lot of statements or functions related to turtle graphics that you can use to draw lines, draw shapes, put text on the screen, etc. Okay, so to use turtle graphics, you import the turtle module, and the way we import a module is with the import statement. So import turtle in a program or in an interactive shell such as idle will load in all the code associated with that module, and it will load it into memory so that it is available to use. Now then, several things you can do. One of the most simplest things is you can make the turtle move forward, and the syntax of that is turtle.forward and then an argument n, which is the number of pixels. So turtle is the object, forward is the method we're calling, and n, like I said, is the argument. So here, if we imported turtle and then said turtle.forward 100, you will see that we now have a line that is 100 pixels long at 0 degrees, which was our orientation, and now the turtle is at the end of that position, 100 pixels from where we started. Like I said, orientation originally is 0 degrees, which they will also refer to as east. To change that orientation, we can move it either right or left by a given number of angles. So for example, here we move the turtle forward 100 like we did before. We go left 90 degrees, and then we go forward 100 pixels. So if we executed these 4 Python lines of code, this is what our graphics screen would look like. Here's an example where we go forward 100 and then we turn right 45 degrees, and then at that orientation go forward 100 pixels. So executing these 4 lines of code would yield this graphics window. You can specify an absolute heading. Instead of saying left or right a certain number of angles, we can give it an actual angle. So in this case, we import turtle, we go forward 50, we then set our heading to 90 degrees, which is up, we go up 100 pixels, We then change our heading to 180 degrees, which is left, go forward 50, and then we set our heading to 270 degrees, which is down, and then go forward 100. So that basically draws a 50 by 100 rectangle on the screen. When you import Turtle, it starts with the pen down, which means as you move, a line or arc is drawn. When the pen is up, we can move the turtle around, but as it moves, there is no line drawn on the screen. The way we accomplish that is with the pen up and pen down methods. So here's an example. We move to forward 50, we raise our pen up, we move over 25, we put our pen back down, we draw a line of 50, we raise our pen again, we go forward 25, we put our pen down, and then we go forward 50 pixels. So basically what we end up with is what looks like a dotted or dashed line on the screen. Up to this point, we've been drawing straight lines or moving in straight directions. We can draw circles. If we use the circle method and pass it a radius, we will get a circle drawn with the center point of the circle being the current location of the turtle, and then it goes out whatever specified radius and then draws a circle for us. We can put dots on the screen at the current location by using the dot method. So turtle dot dot would draw a dot at our current location, which is the center of the graphics window. We can then move forward 50 and put a dot, move forward 50 more and put a dot, and then move forward 50 more. So notice that this function does not need any arguments to execute. We can change the size of the pen and the color. So here there is a pen size method, and we set it to 5, which means when we draw lines or arcs, they're going to be 5 pixels wide. So we set the pen to 5, and then we set the color to red, which is a predefined color, which is listed in the appendix in the back of your book. And then once we change those attributes of the pen, we say now draw a circle that is a radius of 100 pixels. So we will see something that looks like the circle shown at the bottom right of this slide. We can change the background window to any color we want, so it defaults to white. If we want to change it to something else, we can do that. If we want to change the size of the window that we're drawing in, we can do that with the turtle.setup function. So we specify how many pixels wide we would like that window to be and how many pixels high we would like the window to be. So there's some example code at the bottom of the slide to do that. There are several other functions that might be handy. Turtle.reset resets everything back to the default other than the background color. Turtle.clear will erase the drawing that currently appears in the graphics window. Notice that it does not change the turtle's position, the pen color, or the background color. And then turtle.clearscreen will erase all the things that are in the current graphics window, and it will reset the drawing color, it will reset the position of the turtle, and it will reset the background color to white. So clear screen basically takes you back to where you normally start out. with the Turtle graphics windows. As far as coordinates, it uses X and Y coordinates. Again, the center of the screen is 0, 0. And then across the horizontal axis we have X coordinates, and along the vertical axis we have Y coordinates, and any number specified in those coordinates again is in pixels. So we can use relative locations to specify a specific location within this coordinate system by using the GoTo. So for the graphics in the window, we said go to 0, 100, go to -100, 0, and then go back to the origin, 0, 0. There are some things shown here related to coordinates that allow you to query or find the current value. So if you say position, that will give you the X and Y coordinates of where the turtle currently is. If we use .xcor, that gives you the current X coordinate, and if we use ycor, that's going to return to you the current Y coordinate. So we can query information about where the turtle is on the screen. Animation is the actual drawing. There are different things you can do. If you specify 0, animation is disabled, and if you say draw a line that's 100 pixels long, then the line will just appear. If you set it from a value 1 to 10, that will control the animation speed, so you can show the arrow actually being drawn as the turtle moves along the line or the arc. We can hide the turtle. If you don't like seeing that great big kind of arrowhead on the screen, you can use hide turtle to hide it. The graphics are simply drawn, and you will not have a visual indication of where the turtle is on the screen. If you turn the turtle off for a while and then decide you want it back on, you can use show turtle to turn it back on. So up to this point, we've been talking about drawing lines and arcs or circles. We can also put text at the current location. We do that with the write method. So within the argument list, you simply put the text that you want displayed. The lower left corner of the first character will be wherever the turtle is positioned. So here's an example. The turtle's in the middle of the screen, and we ask it to print hello world. So the turtle will not move, but the hello world will appear kind of up and to the right of the current position of the turtle. Sometimes you might want to fill shapes with colors. The way you do that is you issue the begin fill command before you start drawing and specify the color. You do whatever drawing you want, and then you do end underscore fill to stop filling shapes. So here's an example. We hide the turtle, so the turtle's no longer on the screen. We set the fill color to red. We say, okay, we want to begin filling something. We want to draw a circle, so it will draw that circle with a radius of 100 pixels. And then when we're done filling shapes, we say end underscore fill. So these 6 lines of code will draw the red circle that we see in the graphics window. We can get input from this. So this is kind of a crude graphic user interface, if you will. So for example, we can pop up a window using num input if we want to read a number. In this case, we're wanting to input, prompt the user with enter your age and then input a numeric age. If you're wanting to read text, for example, a name, you could say I want text input and the title of the box is input, and the prompt I want to be enter your name, and then the user in that box under enter your name would type a name, hit OK. That would be returned and assigned to the variable name in this case. So basically they're giving you an example here where you can set a default value and you can also set a minimum and maximum. So when you ask for enter a number, you probably should tell the user the range if it's not obvious, but in this case the range is minimum of 0, maximum of 100. And if the user inputs a numeric value that is outside that range, then they would get an error message. When we import the Turtle module and start drawing, the graphics window appears. When we terminate idle or the Python program, that window closes immediately. If you want to keep the window on the screen after the program terminates, then you would use the turtle.done. So that indicates you're done drawing. However, you would like to keep your drawing or your graphics on the screen. So that's a very brief introduction to the Turtle module and how to use it. I have a feeling I'll probably make an additional supplemental lecture on Turtle graphics, but that finishes up chapter 2. So here is a summary of what we talked about both in the part 1 lecture and part 2 lecture of chapter 2.